that is part of the GBEP webinar series for 2023. My name is Tiziana Pirelli and I'm the coordinator of the Global Bioenergy Partnership. And here with me, I have the pleasure to have Constance Miller, the Deputy Director of the Global Bioenergy Partnership, and Maria Valentina La Sorella, who is a researcher at the Council for Agricultural Research and Economics, and Dr. Rodolfo Silva from the University of Sao Paulo, and Roberta Selvaggi from the Società Agricola Assoro Biometano. Welcome to all participants. The title of this webinar is Co-Benefits of Biogas and Biomethane, and it has been organized in the context of the scope of activity group 7 under the thematic area of biogas of the Global Bioenergy Partnership. So I would like to immediately start, but let's wait still a couple of minutes in case some other participants want to join, and then we start immediately with the first presentation. Today the webinar is dedicated more to the use of digestate, but we will also give an overview of the various applications and of the anaerobic digestion in two different contexts. One is the south of Italy and the other one is Brazil. Two case studies, and we love in GBEP to exchange knowledge and lessons learned and to exchange experience between different regions. So, and in this context, we have today these two speeches. The first one is entitled Digestate Production and Fertigation Distribution, the Proficus Recycle of Water and Nutrients through Anaerobic Digestion of Agri-Food Waste. We have an Italian case study, and the second one is High Solid and Wet Anaerobic Digestion Potential for the Treatment of the Organic Fraction of Municipal Solid Waste, a case study from Brazil. So I think that we can start. I have the pleasure to give the floor to Mrs. Roberta Selvaggi from Assoro Biometano. Hi, Roberta, and thank you so much for having accepted our invitation. And we will be delighted to hearing from you. And just let me inform all participants that this webinar will be recorded and the recording will be in available on the GBEP YouTube channel for the next couple of months at least. I will stop here. Please, Roberta, the floor is yours. Thank you so much.
Thank you. I try to share my screen. Okay. Okay. Can you see my speech?
Yes.
Okay. So, good afternoon, everybody. I'm Roberta Selvaggi, and I am the Sustainability Manager of the company Assoro Biometano. First of all, thanks for the invitation. Thanks for the opportunity to share our case study with an international team of scientists and stakeholders. Assoro Biometano is a company made by SNAM, which is the main Italian operator for the transport of natural gas in Italy, in the Italian grid line, and some Sicilian farmers from the Deep Ticino Valley. So where we are a company and our focus is to produce and to sell bioenergy as biomethane. And we want to do all these mission being part of the economy of the region. We are in the heart, in the central part of the Sicilian region in Italy, And our aim is also to recycle the organic matter of our digestate and return to the field with this organic matter. So we need to work on a fully sustainable agricultural approach for all the di Taino Valley. So I will try to explain today our aim and our mission. Assorbiometano is, as I said, in the center of the di Taino Valley in Sicily. It is a semi-desertic area where the temperature is never below than 4 degrees Celsius degrees, and can reach sometimes up to 45 Celsius degrees. So we are a semi-desertic area with an humidity rate from 55 to 75%. And this condition is all around the year, and we have a rainfall average below 600 millimeters per year. Our soils are clay and city, and are poor in organic matter and also in nutrients. So we need to improve agricultural activities and to improve the economic aspects of these activities in all the area. The flow chart of our company, of our plant, is similar to other plant, where biomasses are fed to the digesters, and then the biogas is produced. Then, after the biogas is processed in an upgrading system, and then compressed or liquefied before to be sold in the market. On the other hand, as usual, we produce also digestate as solid and liquid fraction, and we use it as fertilizer in agricultural system. Speaking about operational details in our plant, our biomasses are fed to anaerobic digesters working in wet and mesophilic conditions. So we work with contents of total solids less than 10% and a temperature range from 38 to 40 Celsius degrees. So the biomass goes into the process in about 100 days, more or less, and it is possible thanks to our storage for the digestate. So at the end of the process of this working condition, ensure a full stabilization of our digestate in terms of residual biomethane potential, which is very low, and in terms of pathogenic content, which is very, very low. So the peculiarity, the most important aspects of assorbiometano plant is the diet. In our case, we don't use waste, and there is no land taken away from food or feed production. Our plant is fed only with local agro-industrial residues. And we use, for example, orange pulps, or as I show you in the screen, orange peelings obtained by the orange juice production. And we use also olive pomace and wastewater obtained by the production of the olive oil. And then we use also livestock effluents. Coming from poultry or chicken livestock or from pig farms. So our biomasses arrive from a radius smaller than 50 kilometers, more or less. So we can speak of local chain. When we select these biomasses, we had two missions. First of all, we choose sustainable biomasses for the production of advanced biofuels in order to be in line with the European ILUC directive and Annex 9. So we respect the chain of food as first, feed as second, and energy as last step of the chain. And the second aim was to choose something highly energetic then allow us to produce a high quality digestate with a strong and full potential of fertilization. So here I show you a quick chart with the mass balance of assorbiometano. This is the mass balance of all the process. So we have to start on the right side of the figure, and we have to go to the left side from output to input. That's because assorbiometano is authorized to produce only a fixed amount of biomethane, which is 500 cubic meters, standard cubic meters per hour of biomethane. So the fixed condition determines the mass balance. In order to achieve the biomethane production for the anaerobic digestion, we use more or less 75,000 per year of biomass, and we had about 4,000 tons per year of rainwater. So we have a lot of storage for our biomasses before to feed digesters. So as difference between biomass and biogas, we have the amount of digestate. We produce more or less, as you can see, 70,000 cubic meter of raw digestate in an year. And then we separate it as solid and liquid fraction to use in the best way. So, as I already showed you, assorbiometano yields around 4.4 million of standard cubic meters of biomethane per year. And moreover, also the sales chain is very local as biomass chain, because all the customers are placed within a radius smaller 100 kilometers for our site. So again, our peculiarity is working local. With this quantity of natural gas, it is possible to do 74 million of kilometers by a household methane fueled vehicle. And most important of all, we are saving more or less 8,600 tons of carbon emission from fossil fuel. In other words, assorbiometano is yielding to benefit both for the economy and of all the region and for the sustainability of the transport chain. Now, here is the best from an agricultural point of view. I'm an agronomist, so this is the part of the chain I care about most. In this table, I have considered the typical value of the characteristics of the parameters for all the fraction of digestate which we can sell. Today, we sell the separated fraction, never the raw materials, because of our internal organization of the storage. In particular, I would like to show you what we have built near the plant. About 300 meters far from the digester, from the plant, we built a digestate lagoon. It is able to contain about 40,000 tons of liquid digestate, and is a storage for the winter period when we cannot spread digestate in the lands. But not only a storage, because to this lagoon we have connected, as you can see here with the red lines, we have connected a tube line with specific sampling points where we connect an umbilical system to spread digestate. This is a solution with a high efficiency of distribution, because in 8 hours of work, we can spread 1,000 tons of digestate. So this system, we spread digestate in about 50 hectares in more or less 4 days. So it is important for us. But before continuing to talk about our digestate, I would like to briefly introduce the composition of typical agricultural soils of the Dittaino Valley, where our digestate is usually spread. The digestate of Assoro is spread on around 2,000 hectares of agricultural land. And in this table, I show the soil's composition during the summer of 2020, when no digestate was yet spread. These analyses were conducted by Corteva Agroscience and Pioneer Seeds, which are Italian company which help us for the starting up phase to study our soils and our digestate. So as you can see, and as I said before, in the area there are clay and silty soils, poor in organic matter, and with a high level of sodium. So we can say that this land are under a serious, or is better was, under a serious risk of desertification before our digestate spreading started. So after only 2 years of using digestate in the Dittaino Valley, we conducted the same sampling and we did new analysis. So after only 2 years, all the numbers increasing, as you can see, with better results for organic matter, nutrients, and micronutrients. And it's not all about numbers, because in addition, our digestate allowed us to reduce the need of synthetic fertilizer to avoid the problem of odor emission when compared with effluents, and reduce the potential pathogenic content by livestock effluents. So increasing the humidity of our soil, we can reduce also the water need for the irrigation. See, with all these, we can conclude that Assoro Biometano is working to stop the desertification process of all the Dittaino Valley, with a strong contribution to the sustainability of all the region. But as I said before, we produce also a solid fraction, a palatable fraction, and it has a higher content in nitrogen. So we use it for perennial crops, which are a typical condition of all the Mediterranean area where we are. And this is a specific condition of our area, because in the northern region, where the digestate is widespread, there are no many perennial crops. So we have to invent, to set up machines and distribution systems. So as you can see in this photograph, with the support of University of Catania and others local stakeholders, we are doing distribution tests on citrus orchards, adapting manure spreader. These are photographs of our experimental activities. And we are trying to solve the problem with some solution also for vineyards. We are working for perennial crops with high level of income, and because we hope they are able to and willing to pay digestate as a product and for its transport cost. So we are testing different solutions also to measure the efficiency of different distribution approach. But last but not least, I want to share with you only 2 pitches about a new research activity of the Fertimed project. Assoro Biomethane is not directly involved in this project, but I'm the innovation broker of this operational group, which is working for this project, and I would like to show you our experience. Fertimed is a Sicilian project financially supported by the Sicilia Rural Development Program. Is financially supported inside a measure of the cooperation from private and public companies to develop some innovative solution in agricultural issues. Fertimed involves 8 partners, which are 6 farms and 2 institutional teams, and they have to constitute an operational group, and the name is digestato, which in Italian means digestate, with the aim to evaluate technical and economical solution for using an innovative kind of digestate, which is the microfiltered digestate. And this is the rationale of the Fertimed project. The chain to produce digestate is as usual. So in this phase, we have always the same phase as an ordinary plant, but the innovative section is the microfiltering unit. We produce microfiltered digestate starting from the liquid fraction of the digestate. And we are using an innovative plant to produce it by VAM Sepcom and installed in a digestion plant in province of Ragusa in Sicily. So it's another plant, not a solo biomethane plant. So then, after the production, we transport the microfiltered digestate to the farm of the partners, and we use in fertigation system. And after the storage of this digestate, we mix water and digestate in a ratio of 1 unit of digestate in 15 units of water, and use this mix in drip line. So these are all the photographs of our experimental fields, and where we are installed all these units to ensure to set up the mechanism of the process. As I said before, we are trying to microfilter digestate in perennial crops and typical for the Mediterranean area. So we are trying for citrus orchards and opuntia fields, grassland. But we want to produce cladodes as biomass for the digester. So finally, I would like to say that our mission, our company, close the circular chain of the economy of the agricultural system. Because, for example, we use citrus pulps to produce biogas and digestate. We use digestate to produce citrus fruits, and then to obtain juice, and then to produce citrus pulps to start again the cycle. And the same is for the opuntia. We use digestate to produce cladodes, to produce biomass for digesters. So we are a concrete example of circular economy. So thank you all. I hope our case study was interesting for you, and keep in contact always. Thank you.
Thank you. Thanks to you, Roberta. Thanks very much, because all the food for thoughts that you share with us are super interesting. And at this point, what can I say? We look forward to hear in the future what you will discover on the different aspects. But I don't want now to, we cannot go now into a question and answer session. So let me give the floor immediately to Dr. La Sorella for discovering more detailed information on the exogenous organic matter for soil project, a new European project to evaluate the use of amendments in agriculture. So Valentina, over to you.
Okay, thank you, Tiziana. You can see my screen?
Yes, please. Can you put in presentation mode?
It's fine like this?
Yes, it's fine. Thank you.
Thank you. Thank you, Tiziana. Thank you, Connie, for this invitation for the Global Bioenergy Partnership, for this opportunity to share our project. In particular, today I'm talking about a new project from to evaluate soil amendment in agriculture. Within the European Joint Programme on Soil, CREA is running, as you can see from the picture, several projects. In particular, today I'm talking about EON for Soil, external organic matter for climate mitigation and soil health. which aim is to evaluate the best management practices for the add organic matter to the soil, in particular to evaluate the use of soil amendment like digestate, biochar, or compost in agricultural system, which is the context where we are running this project. We need to consider that at European level, there are many activities which generate organic waste, so urban activity, industrial, agricultural activities, and we need to consider that the annual production of bio-waste at European level is estimated to be 1.6 billion tons, which can be divided between 61% waste produced by animal breeding, 25% originated from plant residues. There are small part, like 7% for industrial waste, and another part, 7% as municipal waste. From this estimation, so 1.6 billion, just 40% of your waste in Europe are processed for treatment such as composting or anaerobic digestion, and in this way, waste become resources. So in some way, soil amendment to increase the soil organic matter. The project is a 3-year Horizon 2020 project, which involves different partners from, this is a big consortium from European Union, but there are also 2 countries from outside the area, Switzerland and Turkey. And the project is divided in three main parts. The first one is about the selection, the characterization, qualification, and quantification of this EOM at member state level, the effect of EOM application on the soil, and another part is about the legislation. So the legislation, national and European legislation, and the policy recommendation for the best use of soil. As a CREA, we are currently analyzing the following EOM, the compost, the digestate and biochar, and I try briefly to summarize in this slide what we are doing at the moment. So there are just preliminary findings about digestate. Data come from the Italian biogas consortium, and we need to consider that in Italy there are more than 2,000 biogas plants, mainly concentrated in the north of Italy, Emilia-Romagna, Veneto, and Lombardy region. And the overall diet of the digestate is production is 62% coming from cattle, poultry, slurry, and manure, 30% from silage crop, and just 1 part, 8% from agro-industrial byproducts. In total, we need to consider that to date, the quantification of the food production of the digestate is around 3 billion tons per year. Regarding the compost, here you can see compost, the different compost production, and also here the total amount in Italy is around 2 billion tons. And the biochar production is under development. There are still, in Italy, there are not many companies. There are just a few companies, as you can see from the slide. There are currently 6 companies producing woody chips biochar, and 5 companies deal with packaging and distribution. The total amount of biochar production is around 1,000 tons. So coming to the end, today we are working on the European policy framework. And just to understand the EOM production market and the use of EOM at European level. So we are collecting all the information from member states and also in Italy about different regulation and also about the related restriction and territorial compliance like Nitrate Directive, Water Directive, but everything is related, of course, to the evaluation of the application, the use of this EOM at the European level, national level. So just coming to the end of the presentation here, we are work in progress. So here just to summarize some question, we are working to answer to the following questions. So what are the most promising and suitable type of EOM? And which are the available amount for the application to the soil at the European level? Which are the conditions that make EOM application and production suitable? So from economic, environmental, social point of view. And of course, we are working on the European policy framework in relation to the application, just to give the opportunity to define some policy recommendation for our policymakers. If you need more information about our project, please, here there are some contact, our email, and we are working on deliverable, and most of them they'll be ready at the end of this year. So for any question, please contact us. Thank you.
Thank you so much, Valentina. Very interesting amount of information regarding the digestate in Italy and more in general biogas production in Italy. And I have some questions, but I will reserve it for later. And so now let me give the floor to Dr. Rodolfo Silva from the University of Sao Paulo, who will tell us about high solids and wet anaerobic digestion potential for the treatment of the organic fraction of municipal solid waste. I think that this case study from Brazil is extremely relevant for the future and development of this sector. So please, Dr. Silva, the floor is yours.
Thank you very much, Tiziana. Can you hear me well?
Yes, and can you put the presentation in presentation mode?
Here it is.
Thank you, Iris. Thank you.
So thank you very much. First of all, good morning, good afternoon to everyone, wherever you are. Thank you for the opportunity, to Constance for the contact, and to Professor Suani also for the invitation to this webinar. I will be presenting to you our work, our PhD work back in Brazil last year's, which is entitled High Solids and Wet Anaerobic Digestion Potential for the Treatment of the Organic Fraction of Municipal Solid Waste, specifically talking about the case study in Brazil. I will be orientating this presentation towards the importance of digestate, even though we did also a study of the energy and greenhouse gases performance of 2 treatment plants already existing in Brazil. So I will start now with the outline of what I will be presenting to you today, which is the introduction, giving you some state of the art and general overview of what I'm going to be talking about, and the objectives and methods, some results as well of the research, and key findings and conclusions. So first of all, to put a framework of the situation in Brazil about organic fraction and anaerobic digestion, is that these technologies already exist in Brazil, but they are still a long way to suffice the waste treatment, fertilizers, and energy needs. The organic fraction and also other organic residues are until now a pollution source and still not sufficiently recognized as a valuable resource. So there's still a lot to be done. Specifically talking about the technology of high solid anaerobic digestion is already seen as a promising alternative, and a few remarkable projects have been developed in the country. And some researchers and policymakers are already paying attention to specifically to this technology, and the applicability of high solid anaerobic digestion technologies still remains to be demonstrated, which is one of the purposes of this research. So in general aspects, why do we need these technologies? What is the problem to be solved? And I want to put some emphasis in this, considering that anaerobic digestion is many times seen as a biogas source and we put too much attention into biogas and to produce energy and all this, but we have to try to change a little bit the chip and think about anaerobic digestion as a way of treat the waste as a main purpose. Other problems that this technology solves or faces and tackles is the water scarcity, and also the continuing increase of energy consumption in the country, and of course the supply of large amount of artificial fertilizers and soil erosion, which is a big problem not just in Brazil but all over the world, and the dependence on fossil fuels and large greenhouse gas emissions, and of course linear economic practices. So, okay, in this diagram, we can see an overview of the different types of anaerobic digestion reactors. Some of you may be familiar with some of them or with all of them. I want to show you this so you have a general idea of what it is and what we're going to be focusing on, which is these two technologies. So we're going to do this comparison. We did this comparison of a wet anaerobic digester, one stage, and also one stage mesophilic dry anaerobic digester. So these diagrams or these schemes show very roughly of, so you have an idea of how simple or how complex these systems are. And okay, when we started this research, we had the theory that high solids anaerobic digestion could be a more promising technology for the case in Brazil. And with this in mind, we tried to recognize the advantages of this technology. And as I mentioned before, the importance of organic waste treatment as a first step. Also considering that this technology helps to save some water in the processes, also producing some energy as a second generation biofuel, and producing some digestate as well, of course, as a fertilizer. These three units take us to the nexus approach, which we are considering on, and it's very important. We take the decisions and we see these systems in a nexus approach, not just in the case of water, energy, and food, but there are also some other nexus as water, for example, water, waste, and soil. So we have to take decisions considering holistic perspectives. Also, another advantage of anaerobic digestion or dry anaerobic digestion is that it reduces, of course, the dependence of fossil fuels and reduces the emissions of greenhouse gases, and technical simplicity. So it can tolerate large amounts of impurities and also some, of course, socioeconomic benefits. So starting a bit more deep into the case study, this diagram shows in a very general way what we did. And we did a comparison of two technologies, high solids and wet anaerobic digestion. And we did a comparison of the material flow, the energy balance, and the greenhouse gas emissions. Of course, these two technologies can produce biogas. The biogas could be turned either in biomethane or electricity and heat. And they produce biofertilizers and mitigate greenhouse gases. So the general purpose of this research was to identify the benefits and disadvantages of both technologies, trying to be as much objective as we could. So even though we, as I mentioned, we started with the theory that high solids could be a better technology, we wanted to be very objective to have reliable results. And we did a comparison on the effects of water savings, waste management, nutrient recycling, energy surplus, and the mitigation of greenhouse gases. And as I mentioned, the way was considering two case studies, existing treatment plants already, one in southern Brazil and the other one in Rio de Janeiro. I'll be talking a bit more about that. And speaking about more about the methodology used, we collected data from primary and secondary sources. So through interviews, questionnaires, we received some files from both companies. We also research or search for articles or papers in internet, everything that could talk about these two plants to obtain as much information so we could have the life cycle inventory, considering all the inputs and outputs of both systems. So the impact categories we analyzed was mass flow, the energy balance, and the greenhouse gas emission mitigation. In order to compare fairly the two technologies, we analyzed the energy ratio and the CO2 savings ratio. So we consider the inputs and outputs of water, organic materials, energy, and also the greenhouse gas emissions as outputs. And of course, doing some emphasis on the digestate that could be produced. Sorry. So these are the treatment plants we analyzed. The wet digester is a treatment plant already built since 2017 in Foz do Iguaçu in southern Brazil. And the dry anaerobic digester is a treatment plant. We started operations about 2 years afterwards, the wet plant, and is built in Rio de Janeiro, in the neighborhood of Caju. And both treatment plants already manage the organic fraction of municipal solid waste. So here are some pictures of the treatment plant in Foz do Iguaçu. So you can have a general idea. Also here is the other treatment plant, the dry anaerobic digester. Here you can see a picture of how the residues arrive to the plant and how they are stored in these garage type digesters. And then they are put into these composting rows and they are turned into fertilizer, as you can see in the last picture. So this table shows a bit of a generality of the processes that take over in both plants. So where the waste is disposed and prepared or pre-treated, and the anaerobic digestion process itself, and the post-processing. I want to emphasize that both technologies produce solid and liquid fertilizers, being the dry anaerobic digester producing also some extra residues of water and solid waste. Okay, speaking a bit more on the results of the research. In this diagram, you can see very general way also the results in considering the mass flow and nutrient balance. And we have an input of about 15,000 kilograms per day in the high solids anaerobic digester of organic fraction. In the case of the wet, it's just 550. We normalized these two quantities in order to be comparable, considering that both plants, the hypothetical case that both plants would treat 1 ton of organic waste per day. And the results show the outputs that the high solid digester produces about 23% of solid biofertilizers. In the case of the wet, it produces 10%. However, from the outputs of this treatment plant, 74 turns into the liquid biofertilizer. In the case of the high solids, it's just 2%. Both treatment plants also convert this mass into biogas, of course, and in the case of the wet treatment plant, 16% of the output is turned into biogas, and the high solids is 8%. The high solids anaerobic digester also produce some other effluents as water or solid pollutant, and 30% of the liquid is recirculated in the treatment plant itself. So the water consumption, as we had a theory, of course, since the beginning, the anaerobic digester, dry anaerobic digester is more efficient, of course, because no extra water is added to the process. Even though the wet anaerobic digester does not utilize large amounts, it just roughly, approximately 50 liters per day. The solid biofertilizers situation is that the dry anaerobic digester produces almost 2.5 more digestate than the wet treatment plant. And also in the wet treatment plant, as I mentioned, 74% turns into liquid fertilizer. And in the case of the wet and the dry treatment plant, just 1.5% approximately. Also, to give some mention of the energy and greenhouse gas mitigation potential, we realized that the anaerobic digester with the wet situation produces about 5 times more, a bit more than 5 times more biogas. So, however, when we compare it, considering the energy input and output ratio to determine their efficiency, we realize that for the dry anaerobic digester, only 26% of the energy produced is utilized for the internal use. In the case of the wet treatment plant, 68%. So that's quite large. Almost 70% of the energy produced is used internally. In the case of the emissions, the greenhouse gas emissions, also the dry anaerobic digester emits less greenhouse gases, about 14% times less. And however, the 81 or the wet treatment plant can save much more greenhouse gases, considering all the biogas it produces, right? So it's about, I think, 5 times more. However, also with the ratio, and we compare both situations and their efficiency, we realize that for the wet system, 6% of the total CO2 saved is emitted. And in the case of the dry treatment plant, only 2% of the CO2 that is potentially saved is emitted. So just giving the key findings and conclusions of the research, we realized that we proved that the high solids utilizes less water in its processes, and it also produces almost 2.5 more solid digestate or fertilizers. In the case of the wet treatment plant, produces, of course, more liquid fertilizers. This treatment plant produces more biogas, about 5 times more. But considering the efficiency, high solid anaerobic digester plant becomes more efficient because it consumes less energy in the internal processes than the wet system. And also, the high solid anaerobic digester is more efficient in terms of greenhouse gas emissions. And as a general conclusion, I want to highlight that both technologies have their advantages and disadvantages. And considering the digestate, both technologies can generate considerable amounts of solid and liquid fertilizers, which contributes to achieve the circularity of the process, food security, and sustainable agricultural practices. So it's very important, very relevant that we take more into account the importance of digestate and fertilizers, and not to put too much attention into biogas, which is also important, of course. But we have to look more into digestate and fertilizers. So thank you very much. You can see here some pictures of the digestate produced in Germany, Mexico, and Brazil. So thank you for your attention and this opportunity.
Thank you so much, Dr. Silva, because you gave us a very interesting view on the comparison of these two types of digesters. And I think that this will raise many questions from our attendees. And let me give the floor to the moderator of this question and answer session and exchange of lessons learned, Connie Miller, who is here. Hi, Connie, the floor is yours.
Hi, thank you, Tiziana. Well, some really interesting presentations today. I mean, I personally have a lot of questions, so I could probably fill up the 25 minutes that we have just with my own questions, but I would like to take questions from the floor. So please feel free to write your questions in the question and answer box, or even raise your hand and we can let you ask your question live. So I'll give you a few minutes to write questions or raise your hand if you'd like to. And in the meantime, I'll maybe just ask one question to each of our panelists. So Rodolfo, maybe I'll go for you first, seeing as you just presented. Sure. It was extremely interesting to me to see the differences, the extremely different composition of the outputs for the high solid and the wet anaerobic digestion. And I wonder whether you could give us an idea of what you think the best context for the use of those two different technologies is, because obviously they produce so many different things. I wonder whether there's a specific context in which those two should be used.
Yes, of course. Thank you very much for the question. As I mentioned in the presentation, both technologies have their own advantages and disadvantages. So it wouldn't be fair to lean towards one technology or the other. But I would say, considering the experience that some countries that already have developed these technologies and have compared them, mostly in Europe or in Northern America, some countries in Asia, we can see that specifically for this fraction, the organic fraction of municipal solid waste, considering that in many countries this fraction has a lot of impurities, we need a more rough and a bit less complicated or less fabricated solution. And that's why I still kind of lean towards the high solid anaerobic digester, because it's just a garage type digester, which is just some sort of huge box where they put all the waste. It doesn't matter. Well, of course, there is a tolerance of 5 to 10% of impurities, but they could go with plastics or metals, and with sometimes goes because sometimes we don't do the proper separation. And in the case of the waste digester, if there's a piece of metal or glass or something, it could cause some technical problems. And there are other advantages as well. As I mentioned, the wet digester can produce more biogas and is more efficient in that situation. But I will say that having as a priority the treatment of waste, I would probably lean a bit more towards the dry digester. And there's still a lot to be done, at least here in America. The technology is very immature, so we have a lot of homework here.
Thanks. That's really interesting to know that it's how well the high solid anaerobic digestion works specifically for municipal solid waste, because obviously correct separation of the waste is a problem not only in Brazil but everywhere. Exactly. That's really interesting. Thank you, Rodolfo.
Thank you.
Moving on, I wonder, Roberta, I was going to ask one of my own questions, but there's a question in the chat, so I'll take that one instead for you. Francesca Varia, she asks, I very much appreciated the practical application of digestate that you mentioned in your speech. What is the limiting factor for biogas in the southern region of Italy? Could you give us an idea of how your company is dealing with low water availability in Sicily?
So yes, in Sicily, we have only a few companies which produce digestate. We have only 6 companies. Biomethane is the biggest one, and we have in electrical equivalent 2.6 megawatt hour of potential expressed by our plants. So it's the biggest one, and we produce the amount of digestate, and we sell all the digestate in the Ticino Valley. So we use it in more or less 2,000 hectares in the area. But the potential for all the island, we have studied it with the University of Catania, is of more or less 500 hectares for annual and perennial crops. So this is not low, and this is good. And our soils, not only in the Ticino Valley, are poor in organic matter. So we need digestate to improve our agricultural soil fertility.
And I wonder whether you could comment on the water availability for producing
I cannot
the biogas.
Listen you very well.
Can you hear me now?
Yes.
Yeah, I wonder whether you can comment on the water availability, if you have trouble with the water required for anaerobic digestion.
Yes, we don't use water for anaerobic digestion. We use only rainwater. And because our biomasses are wet, we have content in total solids in the biomasses of more or less 15%, because we use only agricultural residues with high content of moisture, of humidity. So we don't use a lot of water, and only the rainfall water is in the place near the plants, where there are the street or the office area. So we store all the rainfall water and we use it for the anaerobic digestion process. But we don't use water, other water.
Great, thank you very much. Francesca, I hope that answered your question. If not, you feel free to raise your hand and ask for clarifications in case. I'd also like to pass on and ask a question to Valentina, because the project seems extremely interesting, and I wondered whether you had any preliminary ideas. I mean, I know you're at the very beginning, but I wondered whether you had any preliminary ideas about whether current EU policies are favorable to the use of digestate or not.
Okay. If we consider the Italian legislation is still under development, at least digestate is not still included as amendment, agriculture amendment. So we are working on that. And then we hope at the end of this year to have some good results in terms of legislation. But this is the case of Italy. If we consider the other country, no, the legislation is ready, and of course, if you need additional information, in October will be ready our report with all the information about Italian and European legislation about the use of not just digestate, all DM. So, of course, keep in touch to have additional information on that. Thank you.
Definitely, thank you. I also wondered, a linked question, Roberta, what your perception is of the Italian policies regarding not only digestate, but maybe biogas production in general, whether they are favorable, and if you have any ideas of what could be done to improve the policies. Roberta, did we lose you? Okay, I think we lost Roberta for a second. That's okay. Let's wait for her to. She's still there, but we'll wait for her to come back. So then going back again to Rodolfo then for another question, I wondered whether you could speak a little bit about, given all of the benefits of the high solid anaerobic digestion, why it's not being used more widely at the moment, whether there's a specific limitation for this.
Okay, so in the case of yeah, this is also a question I have actually, because in the case of Europe, it's the technology that is more used for the organic fraction. In the case of Brazil and Latin America in general, we just tend to utilize more the wet systems, but more for agricultural wastes. So the treatment of the organic fraction of municipal solid waste is something in general that is new. A lot of cases in many cities of the region have been developed composting rows or composting treatment. But right now we are realizing that we could also obtain biogas from that. So in the case of Brazil, Argentina, Colombia, Mexico, Chile, we're already developing some laboratory experiments, or in the case of Brazil, for example, there's already a demonstrated plant. So it's very important to keep developing this type of projects to show policymakers and decision makers that this technology is efficient and could treat properly the wastes, could produce considerable amounts of digestate and biogas, and they are promising. And there's not just a tendency, but there is a promising technology that could also generate some funding or some economical gains from that.
So it should be better used, is what you're saying. It's not used enough, the technology.
Exactly, yeah. And I would say one of the reasons also is because there is plenty of space in America, right? In Brazil, we have a huge dimension. So landfilling is still the cheapest and the easiest way to get rid of the waste, which is the case of Europe. And there's a much better you have to look more into the efficient way of using space. However, with the years and cities growing, I do believe that we have to consider better solutions for the treatment of not just organic fraction of municipal solid waste, but also for agricultural wastes and all types of also plastic and the other types of residues.
Fantastic. Thank you, Rodolfo.
Thank you.
Roberta, are you back? I saw you for a second, but maybe not. No. Tiziana, you said you had a few questions at the beginning there, and yeah, please go ahead.
Maybe I can answer to your question about the biomethane. Okay. Today we have a new legislation is about the biomethane incentive for you can transfer your biogas plant to biomethane, so you can have this activity that and thanks to this new legislation in Italy, you get in some way with the production of biomethane money in terms of incentive. So everybody at the moment in Italy, all people working in biogas plant are really interesting to implement this sector. To join you need to consider, as I say in my presentation, that most of the biogas plants are present in the north part of Italy, no? And there are really few in the south. Maybe in Sicily, I think there are just two, no? So with the new legislation, they are trying to implement more biogas plants and biomethane for the biomethane production. And of course, the only problem of this activity is the digestate, because there is a huge quantity of digestate, as you already see, is 3 billion tons. is dry matter, right? Dry matter. So if you consider the huge quantity, and this everything located in the north. And in the north area, we have also a big problem related to the vulnerable nitrate areas, where it's impossible to apply the digestate. I think it's not only a problem in Italy, I think everywhere, also in Europe. So we are dealing with that. For that is important to have a right legislation, because you cannot sell something that is not, you cannot sell something that there is no regulation behind that. So we are, one of the objectives of the project is this one. And for the digestate, I don't know, in other countries, maybe in Brazil is the same, but we are dealing with this problem. So we need to be like pay attention how to about the quality in terms of also a compound, because of course it's important to give organic matter to the soil, but in the right way. So
thank you, Valentina. It's really interesting to hear this. Also, the differences within the country. Know that in some areas the digestate just cannot be applied, and also the problems of the lack of legislation. Roberta has written to me that she can see and hear us, but she can't open her microphone for some reason. So I actually wanted to put this then to Rodolfo about the legislation in Brazil, whether it's slightly better regarding digestate application, whether there are whether there is legislation for that.
There is quite a few policies regarding both biogas production and the proper treatment of organic fraction. In general, in the federal legislation, but also there are also some local legislation, for example, in the state of Paraná or in the state of Sao Paulo, where there is local policies towards the mandatory use of biogas in the lines, in the gas pipelines. And there's still some reforms needed, but there is a huge inertia going on in towards a better use of waste as a resource. And in difference to other countries, in Brazil is already not given as an option, but it's more like being treated as a mandatory step to properly treat the wastes. And this is of course taking some years to idealize this or to manage this in a proper way, but I think there's a good foreseen in this situation in Brazil.
Thanks very much, Rodolfo. So it's good to know that the legislation is also being developed there in Brazil. So I have Tiziana, you raised your hand, and then I also have one question in the chat as well. Tiziana, would you like to?
Yes, sorry, but I think that this exchange is extremely useful because we have different examples and case study of how managing digestate could represent an opportunity or a challenge, depending on the area where we are. In fact, as Valentina was saying, in the north of Italy, it's becoming a challenge because the area that we are available for digestate distribution is limited due to the fact that we have many biogas plants, because there is a lot of feedstock available that is coming from animal raising, I guess. And in the south, we have just a few plants, but we have to consider if it's good to increase the number of plants due to the fact that Sicily is a vulnerable zone for nitrates. And we also see the case study of Brazil, where there are a huge opportunity for development of the sector. Probably they don't have this, and they have very big area, And of course, in Brazil, there are no water limitation, I guess, Rodolfo, and as for instance, here in Italy, but digestate biogas and more so digestate is an opportunity because they have plenty of area and of water, and but the best, let's say, added value is the disposal of organic waste, and so adding value to municipal solid waste, for instance. So I found that these many aspects that we touched today super interesting. So just want to say this. Of course, unfortunately, we are already running out of time. Don't want to, but I think we need to continue this to go more deeply into the many aspects that have been raised today. And I also wanted to thank Roberta for having given the example how to concentrate the digestate, because I think they are trying to find many solutions. So if it's difficult to distribute a huge amount of water with the digestate, as they have this problem with the nitrate vulnerable zones. So as far as I understand, they are trying to concentrate and to somehow distribute us with a lower amount of water, so to reduce the leaching of nutrients. So I think it is we had many food for thought. Thank you. So please, Connie, the floor is yours for closing remarks.
Thanks, Tiziana. Thank you very much. I've asked Roberta to respond to Rocio's question in the chat. So maybe if you have time, Roberta, that would be fantastic if you could write your answer there, seeing as you can't open your microphone. So as Tiziana said, I think there were a lot of very interesting case studies shared today, but also different but very similar, and showed us lots of different contexts where there are different challenges and different benefits of using anaerobic digestion, and different technologies related to anaerobic digestion as well, and the production of digestate. So I hope that everyone else found it as interesting as I did, and I think Tiziana as well. And as she said, I hope that we'll be able to do a follow-up as well, and also to be able to show some of the results of the EU project presented by Valentina. So thank you very much again for being here with us today. And as Tiziana mentioned, the recording will be made available. We'll send that around to everybody after the webinar. So thank you very much again, and have a very nice rest of your day. Thank you.
Thank you.
Bye.
Thank you so much.
Thank you very much.
Bye.
Ciao, ciao.